All right, well, welcome back. It's time for three more shapes and a slightly different idea. So today in this video, we're going to talk about circles, a couple formulas involving circles. We'll talk about rectangular prisms, that's like a box, and we'll talk about cylinders, which is basically a circle extended or projected into 3 dimensions. Now, when we talk about these three-dimensional shapes, like a rectangular prism or like a cylinder, we get to explore one more way to measure this object. So we're not talking about perimeter anymore. Perimeter would work for a circle, sort of. You see, perimeter would be this distance around a polygon, this thing with flat shapes. We can still find the distance around a circle, but it's no longer called perimeter. It's called circumference, and we got a couple formulas for that. We can also still find the area, the surface that that figure takes up. And yeah, it's still in square units. That's kind of weird, isn't it? Even though it's a circle, it'd be in square units. Now, as soon as we get into three-dimensional shapes like cylinders and rectangular prisms, we lose the idea of perimeter. We lose the idea of circumference. We gain the idea of surface area, which we're not going to talk about here. It's a little bit more advanced in this video for here. But we would talk about it for like a rectangular prism. It's not that hard. I'm just going to leave you the formula on that one, frankly. But we also gain this measurement of volume, the amount of space something takes up. So perimeter and circumference is the amount of distance around a figure. Area and surface area is the amount of surface that something has, the amount that it would cover. So the amount each side would cover, or the amount that the shape covers on a flat surface. The amount of volume is the amount of space that something takes up. So we're going to start with circles and discuss a little bit about them. Circle's a weird shape, really. If you had to describe a circle to somebody without using the word round, or circular, which would be circular definition, interesting. How would you do it? And it's kind of a weird question, but the definition, I'm not going to bust your brain on that one, but think about it for a while. How would you describe a circle to somebody without using the word round, or like a wheel, like whatever, or circular? Well, it's by its definition. What a circle is a set of points that's a fixed distance from some other given point, or the center. So take a finger and take a string and attach it to a pencil and go like this, you're going to get a circle. It's a set of points, a fixed distance. That fixed distance is called a radius. The distance from the center of a circle to the edge of the circle is called the radius. And go around that center as much as you can. You're going to find that set of points, a fixed distance from some given point called the center. So we have this radius as the measurement from the very center of the circle to the edge. The distance across the whole circle through the center is called the diameter. So R would be the radius. Where d is the diameter. Now, a long time ago, Archimedes did a lot of work on this in hundreds of years BC. He discovered the relationship between the radius of a circle, which is really the only measurement of a circle when you think about it. The only thing you can tell people is how much the radius is as the definition of how big or small that circle is. Kind of cool. He discovered this relationship, or helped discover it, one of the guys who discovered it, between the radius of a circle and the distance around that circle. And that relationship is pi. Has to do with this number pi. Pi is a number. It's also something delicious. I love pumpkin pie, but it's 3.1415 blah 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 for whatever. I just heard the other day some girl recited like 505 digits of pi by memory. That's amazing. I can't do that. I have like 4. Well, maybe a couple more than that. But it's around 3.14. It's a transcendental number. It never ends, never repeats. It just keeps on going and going and going. It's not a fraction. It's a very cool number. Anyway, we're getting off track a little bit. So how we discover circumference and area is based on this number pi. I'm going to show you how to figure out an exact value and an approximate value using pi. So we're going to stop right now and do an example on circles. So I want to show you right now what the circumference is and what the area is for a circle. Let's make it a little bit more challenging. And you can know something right off the bat, that there's 2 formulas for circumference. And I hope that this makes sense. Your diameter goes all the way across a circle. So if you have the diameter, you automatically have the radius. If you know the radius, you automatically know the diameter. In fact, if the radius is the distance from the center of the circle to the edge, and the center of the circle to the edge, there's 2 radii for a diameter. Or in other words, the diameter equals exactly the radius times 2. That's where these two formulas come from. So the circumference is pi times the diameter, or pi times 2 radii, because that multiplies to give you diameter. The area, you really have to know the radius to do that. So let's do one example. How about we have a circle where the diameter is 6 feet. Can we figure out the circumference? Can we figure out the area? Well, the first thing that we would need to know is what the radius is to use this formula or to find the area at all. You can get the circumference just by multiplying the diameter times pi. So for our circumference, we'd have pi times 6 or 2 times pi times the radius, 3. Hey, the radius is half the diameter, so this distance would have to be 3. In either case, this is still a linear measurement. So if this is 6 inches, then we would have the circumference being, in either case, 6 pi inches. That sounds weird, like 6 pi inches. What are you talking about? When you are asked for an exact answer, this is an exact answer, leaving pi as its symbol form. So this means 6 times 3.14159, forever not repeating. That's what that means. It's the exact version of the circumference of the circle. Now, a lot of times we want an approximation. So on your calculator, you have a button somewhere that says pi. If you don't have one, if you're using like your cell phone, it doesn't have pi, use 3.14 as an approximation. Some people in the past have used 22/7. 22 divided by 7 is 3.14. It's pretty accurate for pi. But anyhow, use 3.14. So take 6 times 3.14 or times pi, and we get 18.84 if you use the approximation. That symbol right there that I wrote, the squiggly equals, is a way to say that we're approximating. Exact answer would be 6 pi, for sure, 100%. But if you need to approximate it, you use pi, the decimal approximation of pi, 3.14, or whatever your calculator says, and when you round it, you're saying it's about 18.84 inches. That's kind of cool. If you had a circle that was exactly 6 inches across, or if you have let's say you cut down a tree, and it's a 6-inch in diameter tree, you know that it's going to be 18.84 inches around that tree. That's interesting. This is how speedometers work in your car. So it takes the size of your tire, and it takes the number of times that you rotate, and it takes the circumference of how much that tire covers in one rotation and translates that into a speed for you. Pretty neat. Now let's figure out the area. For area, you sort of need diameter, but you need to be able to translate it into a radius. So for our area, the area equals pi times the radius squared. In our case, that's 3 squared. Order operation says you have to square the 3 before you deal with the pi. So our area would be, in this case, since we're dealing with inches, and that's 3-inch radius, our area is 9 pi square inches. Even though we're dealing with circles, we don't do round inches, circle inches, we do square inches. That's the idea of coverage. 9 pi square inches. Again, hey, deal with the pi. That's an exact answer. This circle covers exactly 9 pi square inches. If we want to approximate, do the same thing as before. Take 9, multiply by 3.14. So try that now if you would. And get about 28.26 square inches. So that's how circles work. Circles are related to this number pi. You need to know the radius or the diameter, figure out the radius to find the area. You can find the circumference, the idea of perimeter, but in a circle form. using just the diameter. Now, when we deal with cylinders, cylinders are basically a circle that's projected along some sort of an axis. In calculus, we would deal with this. We deal with these shapes in calculus, Calc 3. But for right now, we're just going to be dealing with the volume. I don't want to talk about the surface area. We're just going to talk about the amount of space that this cylinder takes up. The amount of space the cylinder takes up, well, it's very related, and I hope you see this, it's very related to the circle idea and this idea of another dimension. So look here, that pi r squared, man, that's the area of the circle. Basically what's going on is you're taking the area that the top of the soda can or whatever your cylinder is, and you're multiplying it times how high it is. You're taking that area of the circle over and over and over and over and over again for how high this is. That's why you see the area of the circle times the other dimension of a height. So whenever we go ahead and calculate the volume, now what you're doing, because, hopefully this makes sense, because you're taking the area idea, which is a unit squared, like square inches, square feet, square whatever, and you're multiplying it by another dimension, it can't be square anymore. You're taking inches by inches to get square inches, times another sort of inches to get a third dimension. That's going to be cubic. No matter what you do for volume, you're going to get cubic. So you're multiplying 3 dimensions, a length times a width times a height idea. We do that for circles to get an area. We multiply this, well, especially in rectangular stuff, a length times a width. We have this idea of a surface multiplied by another dimension gives us an idea of a volume. So whatever you do for volume, you're going to get cubic units, meters cubed, inches cubed, cubic centimeters, whatever you want to, whatever units you have, you're going to put to the power 3, power 2. So let's get this straight. Perimeter, units, individual units, so no squares, so just the units you're given. Area, so perimeter and circumference, which is kind of a perimeter idea. That's individual units, not square. Area, you're going to do square. Volume, you're going to do cubed. That's how this measurement idea works for geometry. Let's go ahead and just change this one. Let's say that I have a cylinder. And this is 10 feet tall. So this is some sort of water container. And I know that this is 8 feet across. I want you to do something for me right now. I want you to just take a moment, take 5 seconds, and see if you can figure out what the radius is. Because if the cylinder has to do with the area of a circle, we are going to have to know what the radius is. And it ain't 8. So what is the radius? Write that down right now. So literally write it down. So our radius would be 4 feet. In order to figure out the volume, all we need to know is what the radius is and what the height is, and use our formula. So the volume for this particular cylinder would be pi. The radius, notice it's not 8. Don't just plug in the numbers that you're given. Really think about this. The radius of the circle that's creating our cylinder as we project it along the vertical axis here, the radius is 4 squared. Hey, stop right there. If you just did that, do you see that you would get the area of the base of this circle or the top, base of the cylinder or the top of the cylinder? You'd get the area of that circle. It's pi r squared. That's cool. Times the height of 10. Now, the order operation says something very specific. It says before you start multiplying, you have to do the exponents first. So you need to get 16, and then you need to multiply by 10. So get 4 squared 16, multiply by 10 gives you 160. 160 pi, look at our units, feet cubed. The idea of volume is a cubic idea, how much space. 3 dimensions here. This cylinder fills a 3-dimensional space, that's power 3. That's the exact value. So if you're asked for an exact volume, you're going to give 160 pi cubic feet, or feet cubed. If you want the approximation, take on your calculator right now, do 160 times 3.14. That would give you the volume idea. That's how circles and cylinders are related. They use that area of a circle and just extend it vertically, 3-dimensionally. I'm not going to do any examples with rectangular prism, but I want to talk about the formulas, just so you see what's going on. I want you to see where this comes from. So surface area, how much area each surface has, and then add that up together, you get the surface area of a figure. Why do we have all the 2's? You think back to rectangles, we had 2 sides and 2 sides that were the same. Back to rectangular prisms, we have 2 faces that are the same that are opposite. So 2 front and back, 2 left and right, 2 top and bottom that are exactly the same. And each of those faces is a rectangle. So we have a length times a height, but we have it twice. We have a width times a height, but we have it twice. We have a length times a width, but we have it top and bottom twice. Add up all those areas and you get the total surface area, square units. Area is always square units. The volume is very, very straightforward. Volume is taking the area of a rectangle and extending it vertically, just like we took the area of a circle and set it vertically. It's just length times width times another dimension, height. Length times width times height is going to give you cubic inches, power 3, or cubic units, power 3, because we're covering 3 dimensions here. That's the idea. Follow the formulas on those ones. We're going to do one more example, see if we can put some ideas from the last section and this section together. And then we'll be good with this, or last video, I should say. So suppose you're given kind of an interesting shape. You have yourself a couple shapes put together. Let's imagine that you need to find the area of this. So this is someone's backyard, you have a house going this way, has a little round out, they made sort of a soccer field or whatever, and you have a 30-foot section, a 50-foot section, and across is 10 feet. Can you figure out how much lawn you need to cover this figure? There's a couple ideas going around here. And let's say that this is square. So that's square. What shapes do you see? Do you see a circle or a half circle? Do you see a rectangle? Do you see a triangle? Do you see a trapezoid? Whatever shapes you see, use the formulas for those shapes and add up the pieces. You can do this particular problem 2 ways. How I'm seeing this is, if I drop this down, I've got, well, there's a 30-foot section here. That's a rectangle. So from here to here, we got 30. Take that away from 50, and we'd have 20 for our triangle. This would still be 10. So we can think about this as a half circle, a rectangle, and a triangle. Or you can think about it as a trapezoid, base 150, base 130, base 250 with a height of 10. I'm going to show you both ways. Either way, we're going to find the area. So what I would encourage you to do for your area is write down this. Don't just try to do it in your head. You're going to miss something most of the time. Write down what shapes you see. I see a triangle. I see a rectangle. And I see a half of a circle. I do not see a whole circle. Or, I'll do this one later, I see a trapezoid and a half circle. We'll see if they work out the same. So for our triangle, since this whole thing was 50 and this part of the rectangle was 30, we have a base of 20, we have a height of 10, and we would cut it in half, 1/2 base times height. Our rectangle is very nice. Our rectangle is a base of 30 and a height of 10. Our circle, please be careful here. I grade a lot of tests and I see a lot of mistakes. I see a lot of people who would do this right now. Go, oh, area of a circle is easy. I mean, I know the radius is 5. Great, the radius is 5. That's what you have to use for a circle. So therefore we get pi times 5 squared. Done. Don't be D for done. Please don't do that. This is a whole circle. That would give you a whole circle. Cut it in half. That's half a circle. It's going to look weird. It's going to be 25 pi over 2. Who cares? You can use your calculator to approximate it. But this is the area for this figure. You've got your triangle, base times height divided by 2. You've got your rectangle, base times height. You've got half a circle, pi r squared, that's 5. pi times 5 squared divided by 2. And then you use your calculator. Just get what each of these are, add them together as a decimal. It's going to be funky, but that's okay. This would give you 100 plus 300 plus 25 pi over 2. Altogether, for an exact answer, we'd have 400, excuse me, we'd have 400 plus 25 pi over 2 square feet. So this whole thing would be square feet, not feet, square feet. If you wanted to approximate it, you'd have to do 25 times 3.14, then divide by 2, and add that to 400 square feet. Now, let's look at the other way. So option 2, what if you didn't see the triangle? No problem. What if you just saw the trapezoid? So the trapezoid has this base 1 of 30, this base 2 of 50, and a height of 10. We're still going to have half a circle, but here I see trapezoid. Notice how I'm writing down the figures, plus half a circle. This makes sure I don't forget anything, and it describes what I'm doing. It describes I'm cutting some formulas in half. So the trapezoid told us that we need to take the base 1 plus the base 2, multiply by the height, and cut it in half, or divide it by 2. The half a circle is exactly the same thing. So we're going to leave that 25 pi over 2. You take the radius of 5, you'd square this 25 times pi divided by 2. That's what we have. Let's see how this works out. So this would be 80 times 10. That's 800 divided by 2. That's 400. You get identically the same thing. 400 plus 25 pi over 2 square feet. No matter how you do it, if you use an appropriate formulas for the shapes that you see, you can't get it wrong. That's the idea about how to do a kind of a complicated figure and find the area of that figure. That's it for right now. Use those ideas. The big takeaways here are your formulas work no matter what. They have to work. Just don't use the wrong formulas for the shapes you're given. For instance, you wouldn't want to use a whole circle area for half a circle. Keep that in mind, work through your example slowly, and I think you'll get it. I'll see you next time. We're going to figure out how to solve an equation, any equation for any variable. It's really important. So I should be able to give you these formulas and say, hey, solve that for W. Hey, that'd be hard, but solve that one for H. Solve this one for R, stuff like that. I'll talk about that in the next video. See you next time.